Hello and welcome to Emergency R, where the goal is to get you going with your data as fast as possible. If you take a look in the description, there's a clickable table of contents as well as links to the data sets that we're going to use today. In this video, I'm going to show you how to import data that you have in a spreadsheet program, such as Microsoft Excel, LibreOffice, or Google Sheets. If you have data that are in a row-column format, but for some reason you don't want to open them with spreadsheet software, perhaps because it's just too large, or perhaps because it was generated by some other computer program and you don't really want to modify the format, you can see another video that I've linked in the description called Importing Two-Dimensional Data with Read Table. If you instead have a file that's a bunch of lines of text without really columns but just one line of text after the other and you want to import it as text, I recommend looking at a function called readLines. Or if you have your data in some other format, whether it's GIS data or bioinformatics data or anything else, Google is your friend. There are thousands of R packages and probably one of them can help you out. So now let's take a look at how we would clean up our data and prepare it for R. What I have here is an Excel sheet containing some data from an agricultural experiment where we had a bunch of plants planted out in plots in the field, and then we took some measurements on those plants. So the first thing I'm going to do is take this Excel sheet and I'm going to save it under another name because I want to be able to make some changes to it. So here, we'll put it in the same place I already have it, and I'm going to add the word cleaned to the end of the file name so I know for myself this is the version of the data set that I've cleaned up. Okay, the next thing I want to do is make sure that the data are completely rectangular. So it should just be rows and columns in a perfect rectangle and nothing else. So one thing I want to get rid of is this first row here where I have sort of a table caption for this data. That's not something that I want to have when I import into R. So I'm going to delete that row. And if I scroll to the bottom of this data set, there's also a footnote that someone left here saying, oh, the question marks means something was wrong with the measurement. That's also not really part of my table, so I'm just going to delete it. So the next thing I want to take a look at is how did I code my missing data? In most cases, in this one, the cell is blank, and that is a perfectly acceptable way to indicate that data are missing. The worst possible thing you could do is put a 0 in place of missing data, right? Because 0 is a number that should not mean missing data. If it bothers you to have blank cells, if, say you want to fill something else in there just to have something there, if you do capital N, capital A, that also indicates to R that data are missing in that cell. So I could fill things in like that if I wanted to. Now, if you've already used some other symbol to indicate missing data, you might do a find and replace. So I'm going to hit Control F, and then if I do this, I could type in what indicated missing data and what I want to replace it with. So say I had used a lowercase na and I want an uppercase na, I might do something like that. And I recommend matching entire cell contents so I don't get like pieces of words and things accidentally replaced. The next crucial thing that you have to consider is that all of your numbers are properly formatted. And the reason for this is that if anything in a column doesn't look like a number, R is going to treat the entire column as though it's text. And that's probably not what you want. You see I have a lot of numbers here. I want to do math with them. It's important that they get imported as numbers. So what I'm going to do is, in this case, I'm going to do some conditional formatting. So I'm going to make a new rule here, and I'm going to use a formula. And so let's see, that's cell J2. So I'm going to say not, and then or, and then I'm going to put in a bunch of conditions that would be okay for me. So I could say is number J2 or is blank J2 or J2 equals NA. And then a closing parentheses for the or and a closing parentheses for the not. And so if none of these are true, that means something else is in there that I don't want. What I'm going to do is I'm going to fill that in bright red so I notice it right away. And then what I'm going to do is I'm going to copy this and I am going to scroll down and select my whole sheet here, and then I am going to just paste the formats. Right, and I might want to also, I have some numbers over here. I can do it for these numbers too. All right, and I'm going to save that. You know, that formatting is not going to come out in my final product, but since this is an Excel sheet, I can keep it. So as I scroll down, I see some things that are bright red. For example, I have this place where the question mark was filled in, and you remember from the footnote it said that question marks mean that something was wrong. At this stage, if something was wrong, I just want that to be missing data, right? There are thousands of measurements here. I probably can't go back to our field hands and ask them what happened with this particular measurement because they probably don't remember anymore, right? This was something that should have been fixed at time of entry or not at all. So I'm going to delete that and make that a blank cell. And if I keep scrolling, I see some other question marks that were filled in here. And then some other errors, like for example, someone accidentally typed 2 decimal points. So I'll delete that and fix it. That happened again here. And since I keep finding question marks, like if I scroll down, there are more of them. I might want to do a find and replace on the whole sheet to get rid of them. One thing you have to be careful with, so I'm going to do tilde and question mark. If I searched just for question mark, that's going to give me pretty much everything that just has a single character in it, which is not what I want. So if I search for tilde question mark, that's going to search actually for a question mark and just a question mark. So I'm going to replace all with NA for that. One last thing I want to do is get my column headers into a format that's going to be easy to work with when I get into R. What you want to keep in mind is that you are actually going to be typing those column names in order to work with your variables. So you want it to be something that is going to be easy for you to type. There's some autocomplete available in RStudio, but still it's going to make it easy on you to have it be short names that are meaningful. Another consideration is that you don't want special characters or spaces. You can have numbers, but the variable name, the column name, should not start with a number. So for example, I have this entry number here thing, and that pound sign is not going to get imported properly in R. So I'm going to put underscore NUM. So I generally, for separators where you would normally want a space, I suggest using an underscore. A period is also okay. I'm going to put an underscore. It's easier to read, I think. And so then I can go and fill that in for some others. Maybe my spring survival, I want underscores instead of spaces. And here these parentheses also aren't going to get imported properly. And in this case, I'm just going to delete all of this because I can look back at my protocol to see what my units are. It's not going to be meaningful in R to have the units in the column name. And maybe I don't want to type out compressed circumference every time, so I'm going to put in an abbreviation for it. Maybe I'll do that over here too. Total comes as okay, but I'll get rid of that space. Maybe I'll shorten down reproductive to repro. Make a short name over there. Right, and these are abbreviations. Okay, they're not great because they might not be meaningful to everyone, but they're meaningful to me. And I can make a little key for myself, maybe another table in another file where I explain what they mean. Maybe I'll just call this one yield. Right, and now I have some nice short column names that will be easy to work with when I'm writing my scripts. Right, and they don't have spaces or special characters in them aside from the underscore. Now is a good time to pause and take stock of what you've learned. So if you follow the data link in the description, you'll find an Excel sheet starting with the letters MCY. If you download that and open it up, you don't have to clean up the whole thing, but select some columns, paste them into a new spreadsheet, and see if you can clean them up to make them good for importing into R. So now I'm happy with my spreadsheet. Everything is formatted the way I want. I'm going to save it. And I'll save as an Excel sheet just because if I want to edit it more, I'll probably prefer to go back to the Excel sheet version. But I'm also going to export to a comma-separated value file, which is what I'm going to import into R. So if you go to this drop-down menu, there are a few options here that go off of my screen a little bit. So one you can use is the normal CSV. I see I have an option. This is probably for the newest version of Excel to use CSV UTF-8. I'm going to pick that one because that's going to be the most cross-platform compatible. In particular, if you're using any special characters like from other languages or something like that, that will ensure that those are going to render the same on Windows and on Linux and on Mac. Right, so I'm going to save that. Right, it's saved as a CSV. So now I'm all done with that and I'm going to close it. And now I'm going to go into RStudio. And what I'm going to do is I'm going to make a new project where I save that CSV. Right, so I selected File, New Project. I'm going to go in Existing Directory since I already have a folder where I'm keeping my data. I'm going to browse to that directory. And then I'm going to make that as a project in R. And that's just going to make it easy for me to find where my files are. Right, so if I look here in my file pane, I can see that there's that file that I just made. Okay, so I'm going to, from this little square here with a plus on it, I'm going to make a new R script. And so I have this text editor up here where I can write my R script. So I'm going to create a name for what this table should be when I use it in R. Something short and easy to type again. So how about I call it MSI underscore data for Miscanthus sinensis data for short. And then I'm going to use a less than sign followed by a minus sign or a hyphen. And that makes this little arrow which says I am putting something into that name. And what I'm going to do is make a command called read.csv, which will read my file and then put the data into that what's called an object or a variable called MSI data. And so I'm going to type in opening parentheses, and RStudio automatically fills in a closing parentheses for me, which is very nice of it. and then quotation marks, and then I'm going to start typing the name of my file, and I think in this case, yes, I just hit the tab key and that gives me some options. So I'm going to select the CSV. And you could just do it this way, but for beginners, and honestly 90% of the time for me, there's one more thing that I want to change or to tell this command, and that is strings as factors equals false. So a couple things to notice here. I put a comma after my file name, after the quote, right? And then after that comma, I have my strings as factors equals false. I put them on two separate lines just because I'm short on space here. You don't have to have a line break. R ignores line breaks unless a line break is at the end of a command, then it figures out the command is done. And so, important to notice here, this S is lowercase, this A is uppercase, this F is uppercase. R is case sensitive, so that's important. And then false is all in caps. And I'll talk in another lesson about why I'm doing this, but just trust me for now, it will prevent a lot of issues. And since this script itself is actually a text file, I'm going to save it. And let's call it reading data.r. You can call it anything you want, but it's important that you have the .r extension at the end of it. And then I'm going to press save. And so I put my blinking cursor up here in my read CSV command, or really anywhere on this first line, and then I press run. And you'll see over here now, I have something called MSI data. It says 8,143 observations of 20 variables. That looks about right. I can actually click on it, and yeah, it might take a moment, especially for a big file, but it gives me a preview of what that looks like. So I can say, yeah, that looks like my spreadsheet. I can see I've got NA everywhere I had a blank. That's good. All right. And then one thing I want to do to make sure that everything I did in Excel was just as I planned is I'm going to use a function called str. So lowercase str, and then parentheses, and then I will fill in the name of my table that I just made. This is technically called a data frame in R. And so I'm going to click on that. It auto-completed it for me. And so with my cursor there, I'm also going to press run. And then down here in my console, in the lower left, I get all sorts of output. So let me change the size of my windows here to get a better look at that. So if I look, I see the name of each column. And it looks like actually this plot column, something funny happened with the name there. So I might want to go back and look at the original file and see why exactly it got formatted that way. But I can see that these first three columns are all integers. That's what this int means right here. All right, range is a character. You know, it's text. That's good because those were, you know, A, B, etc. Entry names are text. That's good. Entry numbers are integers. That's good. Type and location, right? Those also came out as text. And so I can see anywhere I had an integer, it's labeled int, and then num is for anything where there might be a decimal place. So I can see that, okay, all of these are num, some of these are int. So, right, you want to take a careful look at these. Make sure that nothing that you were expecting to be a number came out as a character. And likewise, if there's something where you're sure that everything in there should be an integer, you might want to check that it didn't come out as num here instead. So now I'd like you to take the spreadsheet that you made in the earlier exercise and try doing the same thing where you export it to a CSV, import it into R, and then check that all the columns are formatted the way you expect them to be. Okay, so in the next video, which is called Exploring a data frame, we'll look at this data frame a bit more, but now you've at least got your data into R.